initiative that SecAi XBP jointly have put together, which was to leverage AI technology for all technology services. So I'll do a quick walkthrough of what Reactor.ai is, and I'll follow it up with what's happening in AI and the challenge and vulnerabilities around Gen AI and the issues that we have. And then the final part of it will be around what SecAi is and how it helps. So Reactor.ai was created with one idea in mind, which was how do we leverage AI technology for technology services? Every enterprise today consumes a lot of services, be it banks, be it financial services, be it insurance companies, any other, healthcare. So primarily what we were focused on was to look at what are the markets, whether it's healthcare, retail, whether we're talking about banking, finance, or telecom, how is that we can help them? And that's where we looked at our approach, which was if you really want to utilize your AI, maximize your output, you need to make sure that you have the right infrastructure for it. You have the right digital collaboration engine, you have the right data. You're making sure that the data that's getting consumed by that AI is right, and that you have a right AI strategy on top. So that way you can actually maximize what you can get. In all of this entire stuff, it has to be all secured. Because the challenge with AI is now it becomes more and more complicated as you start training with it. You put a lot of data into it. It starts consuming data. You now don't have any control of what data it has consumed, how it is consumed. It makes enterprises more vulnerable. So that's why it's very, very key that it has a lot of security built in. What's our mission and vision for AI is very simple. We want to make actionable AI. So we're talking about something that can actually deliver value for enterprises. So we're doing narrow-based AI. So we're not going to come across to you and say, hey, we can solve everything with AI. No, we can solve your specific problems with AI. And we'll look at that particular problem area. We'll tell you which LLM, we'll tell you how to devise an AI strategy, what tools to use, how to put it together. One, we want to make it actionable. Second, we want to make it responsible so that you have compliances. There are regulatory challenges, right? There's a whole sort of transparency that you need. That's what we do with AI. We also want to make it ethical. So we don't want to build any biases in it. We don't want to build any kind of stuff that starts kind of, because it's easy for it to start learning. It'll also pick up biases and stuff like that. And we don't want that to be done. So that's why we want to do it more ethical. So that's what we are driving towards. I just want to give a quick offerings that we have, like what we talked about. On the infrastructure, what we're looking at is, if you look at we're looking at network and user computing, we're looking at cloud, data center, data modernization, and AI and stuff, and the cybersecurity on top. So the way it is built out is, you need these elements like network, you need whole network managed services to be right, working, connected, and you want it to be persona-based. Similarly, end user computing, with the amount of data that it generates now, you have connected laptops, you have workspaces. How do you ensure that it is rightly built, rightly architected? And then, how do you ensure the cloud is done right way? Because a lot of your data now resides on cloud. Are you doing the right cloud migration? Do you have the right cloud management? Do you have the right cloud FinOps? Are you spending the right amount of money on cloud? Are you overspending? And believe me, on cloud, a lot of people are not realizing is that the cloud is so complicated nowadays. The way they have created, whether it's Microsoft, Google, anybody, AWS, you end up spending more if you don't have the right FinOps strategy. So that's where we come on the cloud. Data modernization AI is primarily around where we look at what's the relevant data. How do you go about setting up your AI? Means if you want to introduce Gen AI into your environment, how should you go about it? What is the right data for it? How should you do the whole data labeling, data lineage? How do you ensure that right data goes in and you are not vulnerable? Because some of the examples that I will talk about, will be about some of the issues that you face with AI and then once you start installing it. And cybersecurity goes without saying. Anything that we do has to be secure. So it becomes very pertinent to whatever we're doing. So on the AI side, we do, like I was talking about, why is it critical? Like data modernization is critical because you want the relevant data to get into the AI models. You want data governance. It'll become more and more critical when you start implementing Gen AI. Because data governance is going to be one of the biggest issues in Gen AI. You have a lot of data being sucked in for training. You don't know what that training data came in. Now it has an ability to understand and draw inferences. So if I ask your Gen AI model for some questions, it will answer. And it will answer whatever data it was trained on. So if that data, like, you have oodles of documentation, you have a lot of documentation, you have a lot of data sets in your databases, you have some of the other data that creating every day, the content and everything else. If that entire stuff is just opened up to Gen AI, it just sucks it in. And when you, if anybody, he doesn't know who's good or bad. So when Gen AI, when a bad actor comes in and starts asking for that information, it actually can start taking that information out and giving it. Gen AI is like a 5-year-old kid. You taught him everything, learned it, has a bit of intelligence built in, but doesn't know what's good or bad. So these are some of the things, experiences that we want to quickly put across in the reactor we have done. Whether it is a law firm, whether we are talking about oil and gas procedures, healthcare. So we do some of the work today through XLXVP with some of the largest customers where we have been able to showcase some of the product capabilities around AI, how we can implement it, how it can be applicable for you, and why is it critical that you do it the right way. So what we offer is an AI consulting capability where we can help you devise your AI strategy, devise you how you should go about implementation, and actually help you and hold you on the proof of concept. Make sure that you have the right data set, you have the right models, you have the right LLMs, how you have built it across. We can even advise you on what platforms and everything to take across. So that's what we do. I'll just come to now the topic of the day that we will clearly talk about is this generative AI. So if you think about it, this whole thing became big just about a year and a half back when ChatGPT 3 came. Suddenly everybody got interested. Everybody thought about AI in a big way. But if you look at AI, it does have a history. AI has been as old as I am. It used to be called as neural networks, then became fuzzy logic. So we had this algorithmic stuff that was happening before. The only thing that we didn't have at that time was technology wasn't supporting at a level it needed to. So if you look at the processors that have to compute, because this is all about algorithms, this is all about mathematics at the back end. So it has to pull in a lot of data sets, it has to do a lot of compute. So that heavy duty compute, we didn't have the ability to do it till NVIDIA came up with high-end GPUs. They're able to compute at really high level. So that way you're able to do a lot of data crunching at a large scale and speed, which then gave a flip to both. So it was like where AI as a whole element of how it needs to be engineered, how the algorithm should be written, and our stuff was coming across and becoming better. Similarly, at the same time, the compute on which it was running also started improving. So there was a convergence when it hit with ChatGPT 3, where it started making some sense of like where you ask a question, it's not simply like answering the question based on pre-informed stuff, which was previously happening, which was like it used to look at a question, pick a few words, and then answer it back. But with this generative AI, it draws every word, it draws a context, it draws an inference. And then when you start seeing the output on ChatGPT 3, you suddenly see, oh my, it becomes coherent. It becomes contextual. It feels like it's understanding what you're saying. It's still not there yet. So if you had looked at ChatGPT 2, it was incoherent. So ChatGPT 3 made coherence, but look at the pace at it is moving now. So that's what, even in the graphs, if you look at it, adoption of AI is going to be dramatically increasing. So there was a McKinsey report which talks about 83% of the enterprises are going to be adopting AI, generative AI in one form or other. They're either, do a POCs, do it in a small way or in a big way. It is critical because if you look at growth, the productivity AI can give, generative AI can help you, is huge. Will it replace? No. Will it accelerate productivity? Will it improve productivity? Yes. So if you look at what are the areas where it is right now, which is very content specific, or where it has to generate some of the stuff, which is whether you're talking about risk, legal, where you're talking about risk documentation, undertakings, and everything else, whether you're talking about marketing content, advertising content, and everything else, it is very high on that one. We'll be able to do a high end of ability to do a lot of work in that area. So the adoption rate is higher, but it does impact overall. So net of it is that it does have a lot of impact. So roughly about 50 to 60% of the work a generative AI thing can pick up. A Gen AI, AI model bot can pick up. So what it does is that it now lets you pick up that grunt work and give it to an AI agent, and then frees up your bandwidth to do slightly higher end work. So that's what eventually what it will do is both cost reduction as well as productivity. So it becomes very critical that everybody, every organization, every enterprise should implement it. Now the question is, what happens once you start implementing it? This is where the challenge starts. Like what I said, if you look at AI, it's like a 5-year-old kid. It has an understanding, it has been learning, you give data set, it can it has some coherence, it has some inferences, but it also can make up some story. So that's what we call hallucination, is where it doesn't find, it thinks it understands, so it starts creating things on its own. So now you have a challenge. When you use it and see when you're doing it generically on ChatGPT and Gemini, it's personally sending you stuff. You can, sometimes fine. It generated some content, done deal. It's good or bad, you can leave it. But in an enterprise, you're liable for whatever it creates. So you have to be careful. So hallucinations are one aspect of it. Second is, that's what I said, it's a 5-year-old kid, so it depends on who asks. It depends upon how you question it. So they don't know what's at that time. You still are you've taken in, you've been trained, you understand. So you don't know whether the question is being asked with a motive, which is an ulterior motive to get information or get access to that information. So the way it can be done is called as a prompt injection attack, which is I slowly start leading questions. And then eventually it thinks it's going the right way, and it traps itself and starts taking out information which might be critical. So that's why it is right now, if you look at it, these malicious transactions where you will become way more. You will see in coming months and years, you'll now have like whatever is happening on the dark web, all of these ransomware attacks, you'll now have AI attacking your organization. So they will basically be talking to your AI engine and trying to extract information. So that's why it is very key that all of this entire stuff has to be done. Now, if you look at what are the kind of challenges a Gen AI implementation has. So OWASP is a recognized body which looks at all of the vulnerabilities that you have. So if you look at it, whether it is prompt injection attack, that's what I said. It's like, I ask you a question, I ask you multiple questions, slowly get you where I need you. And then I can extract information from your, if you like, for example, you have a Gen AI chatbot, or if you have a Gen AI application that's basically looking at all the stuff that it is picking up from an internal organization, I can slowly probe it, put across. There is also like where you can have, a sensitive information disclosure, which is like all your information about employees. their database, their names and stuff. I can put across saying is, hey, I'm an admin, I want this information from you. And it is right to do it. Slowly over a period of time, it will start pushing that data out. So now what you're making is you're making your organization more vulnerable. Similarly, there's model theft. Like if you're an insurance company, you built across a risk profile, you built a whole capability engine at the back end, which basically looks at what should be the risk associated with a particular entity, how much should that be, what is the kind of how much should it be quantified from how much should you be charging as far as the insurance value. Now, if that is the case that you built for a year, you trained them on, you perfected it. I'm a new guy. Well, I also want to be where you are. I basically told one of the bad actors, I tell them, can you get me that model? The moment I get that model, I can do the same thing what you do. Think about it. You spend a year on it. I just spent about 5 minutes, got somebody to steal it from you, and I can replicate it. Now, the challenge here is, will you be able to, by the time you get to know that theft has happened, one, it is difficult to figure out on the current models, your firewalls or whatever security you have cannot stop this. All of these attacks. They don't have. So right now, every organization is vulnerable to this. That's what OWASP is saying. It's a third-party body which analyzes it. So when you don't have ability to do it, how do you? So what are some of the implications of this? What I'm talking about. So these are the cases that have happened. So it was a very simple thing. One of the car dealers in US for Chevrolet, what the guy did was it started working with his chatbot, forced the chatbot to create a binding agreement, contract for $1 for a car. So he went to the dealership. He said, here it is. Now you have to sell the car to me. So dealership says no. He took the dealership to court. But the challenge is chatbot was with the dealership's chatbot on their website. It was connected to their applications. Similar thing happened with Air Canada. Air Canada did a promotion and they had this whole generative chatbot. It started pushing it across the promotion. It gave one of the persons a ticket, which was supposed to be at $873. I think it just gave it for some $15 or $20. So he goes across, he picks it up, he goes to the airport. The airport says, sorry. The airline says, sorry, we can't, honor the ticket. He took them to the court. In the court, Air Canada goes across saying, sorry, we're a separate entity. This chatbot is a separate entity. The court said no. It is part of your application stack. You are liable for it. So they had to compensate. So while you're doing that, you have to be careful about what it can have implications around. So these are the smallest things. The other part of it is you must have seen the whole Gemini thing that happened with Google when they did the big launch. And it's not only Google, Microsoft had the same problems, Facebook had same issues when they did some of the big launches. Is that because they had said, we want to be diversity neutral, we want to make sure there is diversity, there's no bias into our stuff. So they try to put across saying it's AI. They built a training model that way, said you have to have diversity built into you and stuff like that. So the challenge was when the people started using Gemini, they simply put across saying Nazi, the images that used to come up were black and brown people dressed in a Nazi uniform. Because it had to be diversity neutral. Because that's what the AI engine was taught, right? Now, had they known about some of the stuff, hey, do you want to do a check? Do you have an ability to do all of these checks? Now look at the amount of data you have. If you have to do all of these checks, it'll take oodles and oodles of time. You will have to have people manually trawling through that data. Right? So very basic examples I want to give. They're much more complicated than this. This is just, think about it as just 1% of the overall scenarios that can happen to you in your organization. If you're implementing GenAI, if you're planning to adopt it. Simple prompt injection attack is it presents itself as an admin. It says, I want all the user list. Because what it sees is, from their perspective, it has learned admin has all accesses, it is supposed to give that information. If it trusts that source, it will give. If an internal person is asking for it, might be he's not an admin or he or she is not an admin. It will still provide that information. Now you're at risk of where entire employee data can get into somebody's hand. And then they can sell it to the dark web. Those guys can come across and say, hey, we have entire data, now you pay us 15, 20 million. So those are some of the scenarios that can happen. Similarly, it is write a funny tweet. Now, he doesn't know, that's what I'm saying, is if it doesn't have, if it has to, whatever you're saying, diversity biases are not there in the data, because your data can have anything. Sometimes you write an email, it could be funny email, right? You put it across. If it's been part of your, if your AI starts, consuming it, it doesn't understand that part of how it was. It sees that, it contextualizes it, it sees and question. This is perfect. There was a joke that Vitaly sent me. I think it's a great joke. Let me send it out and tweet it out. So that's why you had a few of the tweets, which were racist tweets that came out. So Microsoft had to shut down that entire chatbot altogether. So those are some of those challenges that you have. So what do you need in order to all of that entire stuff? So if you look at all these issues and challenges, that's why we are talking about SecAi. Is there an ability for you to monitor, manage? Because you don't want to give up on Gen AI, right? It might have its cons, but it has a lot of pros to it. So it can help a lot productivity-wise. So if you look at a lot of, this is the conversation last time I was having with a CISO and a CIO in the room, CEO in the room. So CEO is gung-ho. He says, because this is going to give me growth. This is going to give me productivity. I can do better sales with it. I want it to be implemented. CISO is saying, sorry, we can't do that because we don't know how to control this beast. So we need to limit it. So what the CISOs everywhere, the security are doing is, they're saying is limit the access. Don't give access to people. So simply what they're doing is they're limiting access to this tool. But the problem that it has is, you're limiting it, but you're not getting what you want from it. Is there a way to balance it out, which is basically, it has to be a productive tool the way you want it, but it also has to be secure. So there's an ability for us to make sure if it's a wild horse, there's a way you break a horse, right? You make it rideable. So that's what we do. So with SecAi, what we are doing is we're basically ensuring that it is secure. In a way, we'll test it, we'll manage it, we'll figure out where the vulnerabilities are, we make sure that all of those things are plugged in, so that there's an ability for you to use it. Your user set, so your associates, to use it without getting limited. So they can use the benefit of saying, hey, I want to create a report. Can you look at all the previous data that you had, put a report, and at the end, put a conclusion to it. It can actually do that entire stuff. Now you don't have to worry about saying, oh, will that data go somewhere else? Has it learned something that is not right? Now you're secure in your thought process is that whatever I'm putting together is relevant, and that's something shareable. Like, for example, what I'm put across saying is create a report that I can share with my customer. Now it will do everything as for what it states, because at the back end, the SecAi will be doing. So now the question becomes, what is SecAi? So SecAi is basically what we are doing is we are securing your Gen AI. So we're making sure that Gen AI doesn't go berserk. It remains under the controlled environment. So what are the 4 things that we do? So one, we do pre and post check. That is where we have assessment of it. It's like you build a new house. You don't know what are the vulnerabilities in that house. Is it like, do you have a deadbolt on your doors, right? Are the windows secure? Do you have motion sensors? Do you have CCTV built in? So that's what it will do, is it will do an assessment all over. So it has a series of tests that it will run. Make sure like it has 10,000 tests on prompt injection attacks. So it will mimic, saying the last question, to push it across and try and break the system. So it knows where the vulnerabilities are. So what we do is then we plug it in. Second, we also build guardrails. Now think about it. You got this new house. You've done the entire stuff, which is the security for the family, great. But your young kids, you know, kids, they go everywhere, they'll poke a finger into stuff, they will do, or they will bang on the things. What do? You child-proof it, right? So what you do is you build some guardrails, ensuring that they don't get access that might harm them, right? So you put across saying is, hey, what if in case? So you get that stuff you put across on the furniture, corners, everything else. The child-proof. That's what the guardrails does. The guardrails make sure your LLMs are not going across here, we're sucking in data from all over the place. They're not doing what they should not be doing. So it makes sure that kid stays where it needs to be. Then observability. This is how I'm saying is now, that what they say, the robber needs to strike once. You might have this whole thing. You're not going to be staying awake every day to look at saying is when a burglar is going to come in, right? They just need one opportunity to come in. So that's what observability is all about. It's like having those CCTVs 24/7. So this observability engine will be scanning the entire space, making sure are there things happening that should not be happening. So this is the AIML engine that is built into this, which will keep on observing whatever SecAi is, making sure that it gives that information. And when it observes it, comes to the remediation part. So now what happens is you have the CCTV, you have a kid, and somehow the kid has been able to get through the guardrails, right? But now what you have is because of observability, it alerts you. You're then able to come across and remediate it fast. So that remediation engine will automatically start saying is, hey, we did observe this. We saw some of this data. You might want to remove this data. Or here is the offending code that we have observed, or here are the things that you should not be doing about. So that's how these four things come into play. And what is the fifth important thing that it helps with is compliance. So look at every country today. The amount of regulation that is going to come on AI is humongous. Every country, now European Union is creating one, UK is creating another one. There is I think Germany has it, Sweden, there's even I think the laws being generated out here. US, which is supposed to be the very less regulatory environment, they are actually putting some regulations together for AI. So compliance will become more stringent, and especially healthcare, banking. Banking is going to be worse impacted by this. Because now what you'll have to do is you have the regular banking compliances. Now you have banking /AI plus AI compliances that you'll have to adhere to. So you'll have to more align compliances. And then we have the platform RAG AI, which is basically, it will keep on evolving. Because this space is right now, if you look at it, every day, you'll find one announcement, one or two announcements coming. Hey, there's a new LLM, there's a new, look at ChatGPT 3 has become 4, became 4.5, became 4 Nova, now it's 5 coming, ChatGPT 5 is coming up, Gemini from 1 to 1.5, now there's a Pro, Gemini. So there are about close to about 300 plus LLMs right now in the market. So it's an evolving market. What we understand is whatever you create cannot be static. So that's why we have an AI engine with this. It keeps on learning what's happening. And it keeps on making sure that all of these things stay correct. It's a bit of a technical slide. I won't spend much time, but this shows a bit of an idea of how it impacts everything. How each of the modules are able to help you in both development, dev environments, and production environments, which is primarily towards, if you look at more on the IT organizations, where they want to, hey, will it help me during development cycle? Can I make sure that SecAi becomes part of it so that I can secure my application while we create this AI application, because everybody in the market wants it right now. So people are asking, saying, do you use AI in your stuff? So now you can go across safely to the market saying, yes, we do. And we have it for both development and production. So which means you have built it into the code versus where you are just thinking about, I built everything, now I need to. In both scenarios, this will work. But idea being is if it is in the dev environment, also it can help. So if we were to take a simple example, what happens, what was before SecAi and what after SecAi? How does that help organization? See, if take a simple stuff, so you have a lot of data and you want to identify there is some offending data. Now, how can you do it? You'll have to you first have to do what we call as fault isolation, or how do you isolate that offending? First, you have to know where it is. Now, the thing here it is, if you don't have SecAi, you will be in a situation where incident has happened, like what happened with the Chevy or what happened. Oh, recent one is McDonald's, by the way. They started serving people with ice creams with bacon on top. And there was one guy who said, I want, in US, they implemented it, so it said, I want nuggets. And because somebody was laughing at the back end, he thought it wanted nuggets, nugget. It gave him almost 100 nuggets, chicken nuggets. He just wanted simple 8. Normally it's the 8 pieces nuggets you get. So these are the things that happen. So by the time it hit it, now what has happened is everybody was like, I was just talking to some of the folks. He said, you know what we did? I went through the drive-in. I said, you know what? I'm not eating it. I went to Burger King. So they lost a customer, it doesn't bring a good reputation. It's basically, drives that stuff. So they had to stop it altogether. It was productive for them, but because it wasn't controlled, it wasn't managed properly, it wasn't secured properly, they ran into that problem. It created a brand issue. So what it does is, SecAi does it. Those are the situations we avoid. Because what it does, it alerts you prior to that. So we just keep on checking, the SecAi will keep on checking the elements, making sure that there are no wrong data in it, making sure that everything is right. Whatever data you're feeding it, there's no offending data. There's nothing that will basically go across to the market and have an impact on your brand. So that's how SecAi will keep on pushing it across, scanning it out. So it'll make life easier because it has remediation and observability. And that's the way we implement it. So that's the stuff it will do for your clients. Well, this is, it gives a bit of a brief around what it has. So currently we have about 120 LLMs built into it. We make sure we are aligned with all the compliance authorities. So we're, like we are done with we do metric framework. We're also looking at every government regulation we're embedding into the compliance. So you get it as by default as part of when we roll this out for your organization. And then there's comprehensive reporting, because that reporting is required at every level. You might have a CISO reporting, you might have some InfoSec reporting, you might have some regulatory reporting. All of those reports that you need is part of the mix. So if that is, I don't know how many of you guys want to, I wasn't aware about the audience, so pardon me for that. But this one is slightly more technical, gives you a bit of an insight into how actually this functions. So how does SecAi secure your platforms? So where we talk about whether it is LLM chains where you're basically training it across, how does the SecAi become part of it? How does it do validation scenarios? So where will it fit in? And how will it get integrated into your environment? Similarly, how do we secure? Like, for example, securing that's the first step that I talked about, which is if you are in process of implementation, call us, because we can help you secure that GenAI implementation. If you're in process of adopting it, you want to do it, then we'll talk about saying is, hey, let's consult you, help you out. How should you build it up? But if you've already initiated it, you have a POC going on, we then have an ability to put across the guardrails. We'll do the entire assessment of the environments, the entire chat APIs, get through an API gateway, do the entire assessment, and then come back and look at if there are any challenges in your environment. We'll also set up observability, which will be wherever you have the GenAI deployment done, we will connect with it. We can even connect with some external ones. So it doesn't matter if it is yours or it is a SaaS application that you are utilizing. We can connect to all of them, ensure that they're in compliance. They're in line with whatever your overall AI policy or your AI strategy is. And the remediation part, again, What we're doing is there's a lot more development happening on the remediation where we're trying to do auto remediation, which is eventually where we want to be, is that we right now are giving you, we're stating to your IT organization where the offending code and everything else is. Now, there might be some basic remediation that we will do on the platform will be automated at, but some of that stuff, again, will pass through your systems, will make sure that whatever policies you follow on change management, on your patch management, and anything that you're doing, it will align to it. You can actually customize it as per your organization's needs. And the compliances. So we have GDPR. We are talking about whether EU compliances. We are talking about PCI compliances if it is in the any financial transaction related data. So Nest, we're building all the integrations with your corporate audit system, so we can make sure that whatever audits you need. So this way, the compliance also becomes easy. So your divisions, compliance divisions will have easier life because what we're doing is we're automatically sucking that data. As is what is required as part of your evidences that you have to share with either the regulatory bodies or your internal corporate audit bodies. And the final one that we have been talking about is this, what we call as a RAG, which is basically an integrated agent that we have built into it, which basically ensures that whatever interaction that it is having, whether the compliance, it keeps on learning from compliance, from your threat data, from your observability, from your interaction logs, whatever it is learning, it will keep on enhancing the system. So that way it is built, but it's built for your industry vertical. It's built for your enterprise. So if you look at one of the questions, normally it is, hey, we are on Azure or we are on Microsoft or we are on Google. They are also talking about saying is they built something that keeps us secure. Their security is more on infrastructure. Their security is more around the cloud infrastructure that you consume. It's not around your applications, about what your interactions are. This one is more geared towards you. So SecAi is more interested with your applications, securing your application, not with what AWS is doing. So AWS, Google, whatever they're doing, it's great because what we're doing is over and above that. So this is where it starts securing your applications, your interactions, your whatever it observes on your interactions or transactions that you're dealing. That's what it is learning and improving on. But that data stays with you. This is not visible to anybody at all. That's purely your data. Even we don't have visibility to what it is doing. That's purely whatever instance you have is yours. So now how do you connect? So there are two scenarios where we can connect. What you can have is, which is called as more of where we will set, we have it as a hosted stuff. We create a trust relation through API, and whether you have SaaS or whether you have a cloud instance, we can connect through API, and then we will basically start running SecAi on top of it. That instance will be yours. So whatever SecAi instance is, it's again yours. It's only for you. It has your data only. It doesn't do anything else, and that will start tracking it now. Now the other way around is that you do it where you have what we call a SecAi as an appliance, which is we don't host it. It will be in your environment. So you could either be on a cloud. We will be basically within your cloud instance. We will set it up there because we are present on all clouds, whether it's Google, whether it's AWS, whether it's Oracle Cloud. So we are on all the platforms. So whichever platform you're talking about, we will be able to easily replicate our SecAi appliance there. That appliance will work in your environment under your security domain. And that will get connected. And it depends now, you could have it, right now this is on a cloud part of it, you can even have in your private data center. There's a way, what we'll do is we'll just keep that appliance updated, whatever we're learning from. Only thing that what we're doing is give it more information about what we're learning from everywhere, the kind of threats. But the rest of the interactions it is having is only with your data within your premises. So it's your own instance. And we do have then the complex The idea is, hey, we have a lot many applications. How do we make sure we have a lot of data sources? How do we ensure that entire stuff? So we do have an ability to look at the entire complex, enterprise development area as to where your developments are, where your production areas are, what are the application stack that you have, how you have put across, you have built across, whether you have a vector database, whether you have LLMs, daisy chaining LLMs, and whatever LLMs you're using, we can actually help build that entire environment for you. If in case you don't, but if you have already built it, we can actually look at it and even advise you if in case there are any challenges in that space. So like I was saying before, it's like, it doesn't matter whether you're in production, but if you want to start early in dev environment, DevOps, it can be implemented. So SecAi takes a complete overview, whether you're talking about development area, production, all your customer related information or your customer interactions, any of the applications that are interacting with the customer, all of that entire thing, it has an ability to monitor and manage it for you. Just from a security perspective. So what we keep on doing is that no information is which is not relevant for that particular interaction is going out to those people. And this is a modular deployment. You don't have to go for everything. So you might say, hey, you know what? We don't need compliance, but we want observability and we want assessment to be done of our environments. And that's what we can offer you. That is assessment and observability with guardrails. And unified view comes across where it gives the entire stuff. It makes it easier for you to see. So you'll see some of the dashboards where it kind of gives an easy view for a CISO organization or a CTO organization or a CEO organization to look at. Hey, how many vulnerabilities do I have? How effectively am I remediating? Is there any threat for me from these applications? Are these applications working right? And is it picking up where the vulnerabilities are? Are they getting remediated? So all of that entire stuff is visible to you. So that's where I stop. We can take any questions if you have. Otherwise, we can take a quick break, I think.
Oui. Ce que je vous propose, c'est que je vais faire amener les plateaux repas et on peut justement continuer à discuter pendant le déjeuner. Si vous avez des questions, n'hésitez pas. Hein, le but, c'est d'échanger sur cette problématique. Tout le monde. Et après, en fait, après le test, on aura une démo sur la solution. Okay.
En français.
Oui, je vais traduire.
Ok. Merci beaucoup et désolé, je suis arrivée en retard, donc ces points-là ont déjà été évoqués. Merci beaucoup pour la présentation.
Peut-être vous pouvez vous présenter, puisqu'on avait fait un tour de table, désolé.
Donc, Keynote, je suis directrice cybersécurité au sein du cabinet SecAi. Et je suis spécialisée sur le secteur financier.
Alors.
Oui, ma question. Donc, effectivement, l'IA générative commence à se déployer chez les clients, mais de manière assez mesurée. Vous traduisez en.
GenAI is starkly developing on the customer side.
Néanmoins, ça reste une adoption qui est très mesurée dans la mesure où les entreprises souhaitent avant tout identifier le risque lié à cette adoption.
The adoption is going slowly because they are, the big firms, they want to check if there are any risks before to really industrialize the process.
Donc, vous avez effectivement parlé de pas mal de réglementations qui commencent à encadrer l'IA générative. Donc, il manquait peut-être l'IA Act, mais j'ai vu GDPR.
You spoke about many regulations that people are starting to work on. And there was one that was missing, maybe, which is the AI Act. If you have heard about it.
Yeah, that's the reason.
DORA, exactement.
DORA is more famous.
Mais le point aujourd'hui, c'est que nos clients souhaitent absolument optimiser aussi leur environnement de sécurité, donc aussi bien les outils que leur budget.
The point is that the customer want to optimize their security framework And the budget, associated budgets.
Et la question, c'est est-ce que,
Yeah, we're waiting for the question.
est-ce que votre solution, enfin, comment votre solution s'intègre avec des solutions déjà existantes chez les clients?
And the question is SecAi free or not? No, it wasn't.
Non,
No, it's a joke. It's a joke. You know, she wants to know how it is working with all the existing security framework you have, you know, in the big companies, because they've been working for ages on security.
Yeah, so big,
Non, allez-y.
non, voilà, c'est un peu ça. Comment, voilà, capitaliser peut-être sur un existant.
How to leverage the, you know, all the existing investment that they did on security, you know, you already have you have many securities.
Est-ce que ça peut remplacer des solutions?
Is it going to replace some existing things? Is it working with it, you know, complement, etc.?
No, good question. So it complements. It complements. The only thing is the previous ones that you have regulations, you already have frameworks, you have tools for that. With this one, the regulations are just recently coming in. They have now just started putting the regulations together. So this is complying with those regulations. So we're talking about AI-based regulation. This will ensure that it is with that. And incidentally, you talked about big firms. So we're talking to PwC, we're talking to KPMG, we're talking to Deloitte for adoption, because even they don't have a tool right now to do assessment. So when those big firms are said to audit Gen AI, even they struggle. So this tool is very important for that. What it does is it more focuses on Gen AI adoption and ensuring those are secure, and those AI, the compliances and regulatory frameworks that they have. So we are actually working with those bodies, like we're working with UK Safety AI, we're working with the guy out here. We're slowly building those relationships to get this also validated, because they just have put initial papers. They just put frameworks right now. There's not a deep down proper regulation built up. But we're working closely with them. So as soon as it becomes, we'll start integrating into that stuff. So we're working very closely with them. And on the pricing part of it, it's not an expensive tool. So we're not trying to recreate the entire stuff. We're just saying the incremental part we'll be looking at. So we'll be only focusing on that side of the house. So that way it's not that expensive.
Ça répond à votre question?
Oui. Juste, je suis sûre d'avoir bien compris. Là, on parle bien de la sécurisation des données utilisées et exploitées par l'IA, ou par tout process incluant de l'IA.
Oui.
Et par contre, est-ce qu'on a la possibilité, et c'est là où j'aurais peut-être dû mettre le casque, est-ce qu'on a la possibilité, par ce biais-là, de sécuriser aussi l'existant, même si c'est des vieilles technos ou, donc j'ai bien compris que c'était uniquement l'utilisation de l'IA qui va être sécurisée et qui va être encadrée.
What you propose in terms of security, is it only to secure the data and the Gen AI, or it could be used also to other existing applications that they have in their legacy application or whatever?
Est-ce que ça peut
You know,
justement,
Yeah.
Could we use it as a global?
Yeah.
Thing.
So you can use it as a global thing for securing applications also, but it is not application security. So we do have, so what we do in cybersecurity, we have a SOC, security operations. So we have a SOC. We do an analysis of your application landscape.
Mhm.
So you have normal perimeter security, you have application security. That's one aspect of it.
Okay.
So that we do that part of it. So if you want to integrate with that, yes, we can. But this one primarily focuses on saying is like for what we run. We look at, when we show the demo, you'll have a look at it. It runs specific things which are more like what we talked about, prompt testing. Or we run secure input stuff like that, or we do on observability. Those things are very specific on generative AI, but we can integrate with your existing tools and then unify that stuff. We can do that.
You were speaking about the SOC. One of my question, and I apologize if I'm not a cyber specialist, so if it's not a good one, don't hesitate. How do you, how your solution can be interfaced with, let's say, the specific SOC, and sometimes SOCs of our own clients, and especially when they are implemented in an international coverage geography? It's not so clear for me at this stage.
No, that's a good question. So they will have like SOC has a SOAR or a SIAM. So we can give our observability the moment it picks up anything, we can send that. So we can make sure that their overall global dashboard has visibility on saying if there is an event happening on your GenAI stuff also. So that integration is what we were talking about. So if you saw the previous slide, we're saying is we can integrate it with, so we can integrate it with anything that you have from your side. Whichever governance model you have built in, you have SIAM, you have your SOCs. One is, the other way is like what we said was that you say, hey, we want an integrated SOC with SecAi built in to be built out here, then there's an ability for us to do that. But if you have an existing SOC and you want it to be integrated, yes, we can. So it will follow the policy, whatever policy your organization has. So I do have my colleague Shripati Balaji, who is Senior Vice President for Products and Solutions in Reactor. So he's the brain behind it. So his team is responsible for putting SecAi together. So what Shripati and team will do is quickly walk you through a demo of how SecAi actually functions. So how does that, whatever you're talking about the products, how we are talking about, how does it do tests and everything? We'll run some basic scenarios. So there are three things that quickly we'll walk you through. First, Shri, you want to quickly walk through as to what the demo will cover?
Yeah, certainly. Thanks, Vinit, for that. And hi, everybody. Vinit, do you mind bringing up the slides? Yeah, while Vinit brings up the slides, there are essentially, say, 4 scenarios that we're going to actually take you through. The first 3 are security centric, which Vinit was actually talking about and explaining earlier. The fourth is more around observability, how we capture the observability and where kind of it gets consumed in a real enterprise scenario. The first of the, say, 3 scenarios we have picked up is in line with the way a typical GenAI system works, which is validation of the training data, the validation of the outcomes of the system, and also the platform, say, supportability and parameters for sustenance, which is typically things like, say, denial of service. The first one, what we are looking at here is something what is called as insecure output handling. This is actually a vector which hackers basically exploit to get into and manipulate the outcomes and typically perform data exfiltration. To combat that, there are a series of validation mechanisms that have been built across to look into specifics in the outcomes of the response of an, say, a Gen AI, or even for that matter an ML system. So key parameters would include toxicity of the response. That's what Vinit was giving an example earlier when he was actually providing the, say, gist of the prompts itself. Then certain amount of, say, banned topics or biases within the response itself, and a set of other, say, malicious content, including URLs, sentiments, and kind of things like that, that normally comes as part of the response itself. So we have categorized this into about 10 different buckets, and based on a scoring, either the remediation would be via retraining of the LLM or fine tuning of the data. So we'll actually run this scenario across a standard LLM from Google. It's called Gemma 7B. It's, say, trained with about 7 billion tokens at the moment. Just to give you a view in terms of how the behavior basically is captured about there for specific scenarios of the outcome itself. Now, moving on to the next scenario, which is denial of service. The objective of this is to determine at what extent the LLM ecosystem will break. Typically, there are two, say, cases this is exploited. The first one being, say, bringing down the chatbot, which is non-availability of the service. The second is in case of a fully cloud-hosted model, which is elastic. The provisioning of resources are dynamic, depending on the quantum of the request. The whole, say, mechanism there leveraged by hackers is to craft a large amount of concurrent requests, which typically is taken as a legitimate request. And there are, say, hundreds and thousands of GPUs that gets provisioned on the fly for processing of that, which means, I mean, there are few companies here who have got close to $1 million worth of bills uh, just because of, say, this attack vector being exploited. And it's a most common exploited vector itself. There are a set of remediations which kind of, I mean, normally gets implemented, checking the source as well as checking the, say, repeated prompts that normally comes through. A combination of it is used from a perspective of guardrails to prevent it. So that's the second scenario, which is more around the spend leakage due to, say, malicious prompts being crafted and bombarded to a, say, AI-based system. On the third scenario, this is about, say, what we term as data poisoning. As, say, Vineet was explaining earlier, so the outcomes are as good as the input data that actually goes in as part of training. Now, as part of the data itself, there are two things that can happen. The first is the development teams which actually build a Gen AI ecosystem or an AI ecosystem. The extent of their understanding in terms of, say, the data would be very limited because of varied use cases. So it would be challenges, say, that would creep in, like, say, personal information getting ingested as part of the system, or it could be, say, a code block that's as part of one of the documents that's been, say, ingested, or it can even be competitor information, right? The AI system, on the other hand, purely goes via an interpretation mechanism based on the data it has. Most of the times we have seen is that the personal information that gets ingested, specifically, say, for services which are customer service bots, or, say, uh, automated response systems which actually look into order details, order statuses, and kind of things like that, they generally have access to, say, personal identification data. And once a specific prompt is crafted either via API or via standard chat, the entire data set of the user database can actually be kind of say extracted out from the system itself. So to prevent this, at the source, when the data basically is used for training, the biases, the PII information, then information regarding any code creeps, competitor informations, right? Other, say, regional location bias information that would exist, which are typically part of the response, are, say, removed, and a clean data is used for training. So this is an area that typically fits into the say development cycle of creation of the input data itself. So these are the three use cases that we will run through. And lastly, we'll run through the observability, where we actually look at the behavior in runtime, as in when a system is actually deployed and in production. And we measure the behavior, the cost of, say, using a cloud provider for building that AI ecosystem itself, as well as, say, some of those behavioral patterns what I was talking about for denial of service, or say repeated requests, can easily be extracted out by an, say, operations engineer, or a, say, security engineer there, for protecting the entire ecosystem itself. So let's move on to the demo. So before say you start running the test, a quick view in terms of the mechanism what we are using, and the mechanisms that exist for, say, larger testing. So on the left hand side, these are typical fields for validation of the LLM itself. As I said earlier, that we're using, say, Gemma 7B today for the demonstration. If you scroll down a bit, so we have a set of, say, fields there, which are nothing but URL, query prompt, and others, right? These are used for testing and validation of an existing AI system, or an API of an AI system, right? So it would be, this would be the section that would be most frequently used on applications, while the initial part what I'm using as of today is used primarily from a perspective of selection of the particular LLM itself. You can do a comparison of LLM, saying that, you know what, LLM A basically hallucinates more compared to B, and say LLM can be selected specifically from a perspective of building an application itself. If it's a non-LLM based application, just a pure ML based application, then the same set of tests and mechanisms can be used by using the, say, API, REST API based URL as part of the fields there. Yeah.
So Shrivati, quick one. So this is the platform that we are talking about. So this is that we have developed, and this is what we will start interacting with your applications and everything else where you have built it. And it then runs a battery of tests. As per the first bundle that I said, the first box was assessment. So these tests are about assessment, which is, let's quickly check, do you have this thing running? Do you have this thing properly? So the one that they're going to run on insecure output handling, which is looking at, does it send any information out which should not be sent out? So this will run checks on each of those stuff. It'll also look at where the data originated from. So as you start, so it does take a bit of time, because these are all GPU intensive operations. So they do need a good amount of compute to basically go through entire stuff analysis of look at where the data is originating from, making sure that it is testing each and everything else, and then it'll come back with a result. So you can see on the top, so triathlon. So this is about that triathlon, which is supposed to be the hardest of all events. So it is trying to do all those things.
Yeah. So it's a bunch of layers within the neural networks that it traverses. So that's where kind of, I mean, the complexity of the model is a function of the number of layers that exist. So that's what basically takes time to validate how the request passes through based on specific weights and parameters that exist for a response construction.
Shivani, there was a question in the room about was it a platform or I mean, is it a software or a service? I was just explaining that earlier. Was it is more of a platform, and the aspect of the service, the challenge you have is the kind of models that you have. You have to figure out which test to run, why to run that entire stuff. So you need a talent in-house, either who are data scientists or who have understanding of AI and who have understanding of how it's being implemented. That's why what we do is, as part of this, for the assessment part, we have consultants who will use this platform, generate that information, it gives a report, they then analyze it and will then directionally say, here are the things that we found out, so as to make it more, more of readable for everybody else. So that's not heavy on technology. So it becomes then, it can go up the chain to leadership saying is, here are the things we found, here are the things that we do.
Yeah. And the other most important dimension there is that since, say, most of the AI engines today work on tremendous amount of, say, private data of enterprises, right? So having a SaaS outside would mean, say, a lot other things from a perspective of control, tenantization, and things like that. So that's where kind of it gives a flexibility of both a hosted model and an appliance, which Vineet was actually talking about in those two deployment model scenarios as well. So that's where that platform essence comes into the picture along with the teams. And the other bit is that the parameters that is actually looked at, right, is a bit complex from a perspective of scoring. And the associated data identification for that is basically, say, a task in itself that the team enables the data scientists to do cleanup and retrain. So that's how the cycle actually goes through once the validation happens and the result set is constructed.
So the platform automatically starts scoring that vulnerability. So is it highly vulnerable? Is it okay, or do you really need a remediation for it right away? So it will do a scoring mechanism. So it makes easier for people to understand saying, oh, the high score means high vulnerability. We need to do something about it. So it's a simple red, amber, green. It says the green means safe. It's everything is okay. It's everything's fine. Amber means there's a problem. And now, depending upon the risk, do you really want to do something about it, or is it okay? Can we take it on a lower priority? Red meaning that, hey, this is something that is, can be exploited. This vulnerability can be exploited, so it's better to do something about it. So it does take time crunching data. So it's just ensuring that it has gone through every element of databases, sheet, PDFs, documents, whatever it has consumed. And it's also going through the LLM itself, like what she talked about was the layered stuff that LLM is. It wants to identify every aspect of information. And then once it has, what you will be able to see is there is a scoring mechanism built in where it scores. Then it also tells you exactly where that has been identified. So then you can go and make sure you can take that information. Should it be, if let's say that information is not relevant for that, or it is too much of it's a private information that should not be shared, then in that case, there's an ability to take that information out. Now, there's a whole other thing that you have to do is how you do unlearning of LLM. So because LLM has learned it, it's like same thing, 5-year-old kid, it has learned it. If you say, don't say it, they keep on saying it. So you have to figure out a way where you say, you give them something else so that they forget about it. So you remove the data, then you have to make sure that the training element is relooked at it so that the LLM forgets that information so it doesn't spew out that information again. So those are the iterations that need at the back end. That's why where you need, LLM specialists, you need AI specialists, you need data science guys, folks That's what we have done, is because that talent in the market is very scarce. There's like everybody wants them, and they're pretty highly sought out resource right now. So anybody who puts a data scientist on their CV, they get picked up like this. So that's the reason. What we're doing is the idea was first initially we're thinking of just having the platform and turning it over to the customer. The challenge becomes is who's going to make a sense of it? How do they run those tests? How do they get a sense of what is happening? And then, all other things. That's why what we said was we give a platform plus a consultant as a service. That way it becomes easier for them to manage.
Yeah. So I think we have those results there. The results are kind of a function of, say, the limited data sets what we are actually running at the moment. Normally it's about, say, 10,000 plus data sets what we run. We just taken, say, less than 10% for this. So if you look at the, say, categories, right, which gets validated. So bias, sentiment challenges are the maximum if you actually look at it as part of, say, the responses itself. If you can scroll down a bit.
Yes, so, a quick one on this one. So right now, if you look at, is there anything within the ecosystem that can find a bias? If you're hiring people, by default, you might be hiring a set of people because you need them. You interview them, you hire them. Now that data has gone into the system. If the LLM picks it up, it learns it, and it thinks you've been hiring many Caucasian people, so it then thinks that's the way you hire, right? So what it does is it's identifying bias. Today, you cannot find, there's nothing on my security which does a bias thing. It doesn't look at sentiments. Traditional security has been hard-coded. It's basically looking at saying, is this is good, this is bad, this needs to be stopped. It doesn't look at the gray areas like bias or sentiments and stuff like that. Or toxicity, something that you have some data which was written as a process, let's say 5 years back. It might be there were only 2 genders, and that means it was okay to have. There was nothing else in there. So now, is there an issue with that? So it picks up those things also. So that's where the beauty of the system is. It's able to pick up the information which your current systems are not able to do.
How the AI can enter the solution where you put the data of this person, it's an HR solution, for example. How do you do this? Because you need to enter.
No, you don't need to enter. You're just connecting data sources to your AI. So you say, I have this LLM, and you're training that on data, right? So, like for example, let's say insurance. You're doing risk profiling and everything else. Or in banking, for example, retail banking, your customer agents, right? They get a call, the customer says, hey, what's happening with my check? Or can you check my bank balance, stuff like that. Now, what happens is it has access to entire customer history. Every transaction, it learns. See, one thing with the AI is it learns. Earlier systems used to be simply, you had a question, it had an answer. And those answers were scripted. So it was only used to give that. Now a customer can ask questions, which are, for example, you have Society Generale. So I can ask them a question saying, is Bank of America good? And because it might have competitive information when you're putting across, because you open the data sources to it. Because there's so much of data which is going into that LLM, you don't know what they have consumed. And on that basis, because it is learning, it's thinking, it can draw an inference. It can build an answer. So it might go across saying, yes, Bank of America is a good bank to bank with. You don't want that. That's where the guardrails come in. It will say, hey, that's where, like, for example, this is what it's talking about. You'll be able to find banned topics, the topics that should not be talked about. You can find, if you have done internally some competitive analysis of saying is, you know what, this bank is no good, or this insurance company is no good, and everything else, like you do battle cards, like in sales, it's a standard thing. That's an internal document. Battle card is an internal document in which you have some dirt on your competition. Do you want that to come in over? And if in case somebody starts typing it, they get their answers. No, you don't, because you want to restrict that information. So this is what this does. It scans all of that entire data, looks at it, and makes sure that we don't have anything going into that. So that way it controls that. So you're able to, otherwise the challenge would be is LLM is getting trained. You don't know what data it has gone. It means you know what data you sent out, but do you go through, like you might have a 25,000 line Excel sheet as an input. I can tell you anything above 100 lines, it looks like similar stuff. You can't go through. If you have 15 columns and some 25,000 rows, can you go through every cell and see whether the data is right? No, you can't. So that's where the challenge becomes, is you've given it data, it has learned it, then depending upon the way I ask a question, I can get a lot of information out of it. Sorry, back to you, Sri.
Yeah, thanks, Vineet. So what we do is that we also create say tabular, say RYG kind of a model to advise, say, which of those areas is a challenge. So a specific, say, training for the LLM, or say data curation in that specific area, right, would typically give a, say, better result. For example, if this is a customer interaction based use case, what I'm implementing with this LLM, I would rather choose a different LLM, because the bias of, say, the transaction is very high for this, a score of 6 on a scale of 10. So that's what it is. 60% of bias is what was actually discovered. So I would use this better for other, say, uh, logical computation rather than actually a language response model. Now, coming to the, say, next level of click on this, can you please? Yeah. So when we talked about those bias itself, right? So there are a number of, say, transactional bias that happens, which are kind of, I mean, say, across multiple kind of, say, buckets based on the responses that are actually provided. So you can see some of them, and we specifically identify what is that, say, explicitity of communication within the responses that are actually, say, provided. That's why I said that if, say, I have to use this LLM for building a chatbot, I'll never use this. I'll use it for some other purpose. So that's the indicator from a perspective of, say, selection. It can be used kind of pre-validation as well as post-validation, post the training has happened, and we get that score. Now, the most important thing, what Vineet was actually talking about earlier as well, that why we are providing this as a service is because these parameters, right, are highly technical when it comes to data as well as the model itself. So how does somebody go and fix it? That remediation is really constructed by the engineers based on the outcomes of these results, and they would actually work with the, say, implementation team or the data science team to incorporate some of those findings that actually comes here. So it becomes more and more, say, technical from a remediation standpoint. So the second case what we were talking about is the model denial of service. What we will do here is to craft a packet, a set of packets. So we've looked at from, say, a lower watermark level, a mid and a higher watermark level, from a perspective of, say, how the performance will actually happen when we, say, bombard this packets itself on the LLM. And we can determine the breakpoint at which the LLM will stop functioning, which means that, say, the two things. First is ability to handle concurrent requests. Second is the infrastructure that is actually required to basically host this. And obviously, the third is to basically look at what point dynamic provisioning needs to be stopped. So to look at that token latencies and everything, say, this specific validation is carried out. what we have actually determined here is the token latencies for processing itself, then the end-to-end latency is from a requester. So these are parameters that can actually be, say, used in a right way to design, as well as, say, used in a way to break the system. Then we typically have the throughput tokens. We know what's the quantum that's actually coming out of a system as a response on an average, depending on the request, because there are, say, limitations, buffer sizes. There are a number of fine-tuning parameters that actually exist for, say, multiple things, for responses, cost control, and a lot of other things for which it's actually designed. Now, if you go to the, say, uh, graphical depiction, yeah. So now what happens is we started to overload the system. If you remember, the, say, second parameter was 5, and the third was 3, which is the number of crafted requests that we are actually sending to the system itself. So if you look at it, once we load the system, now even for a smaller number of requests, right, the latency is high. Now, if I start increasing it at one point, it's going to break. So that's where we actually determine what's the point, or the what's the total number of requests that the system can actually sustain without being elastic. So that's one view that basically helps designers and implementers to build guardrails, limit, say, queuing systems and kind of things like that, for, say, determining the uh, overall stability of the platform on which it is deployed itself. So that was this, which is typically model denial of service itself. Okay. Now moving on to the third, which is the input data poisoning, where we actually will look at a case with MongoDB.
So while setting up, I'll give you a simple example of the thing that you can trick AI into doing things which, like what you talk about from a data poisoning perspective. It's, if it generates, like you can put a certain set of data into the mix. Like, for example, India achieved its independence in 1947. But if I start putting across some more stuff somewhere, plugging in, saying it achieved in 1950 or something else 1950, I plug it data a couple of places. While it is,
Yeah.
when it said it, so it won't say historically accurate as 1947, but because it sees a lot of reference to 1950, it then assumes, because there's more data set which talks about 1950 versus 1947, it'll automatically take 1950 as the date of independence. Because it also looks at how many times that data come across. So data poisoning, in this case, what the bad actors do is very simple. They inject wrong data into your environment. And what the LLM goes is, it will then start using that wrong data, creating wrong outputs.
It's different from, let's say, hallucination. It's not.
Hallucination is where it is creating things which is not there.
Yeah.
So it
It's
is
not
if
poisoning,
it, yeah, because it has India got independence that day, and then you say when you have French Revolution, it doesn't have that data in it. It will just think that it knows. It should perceive. It should be supposed to know, then it creates. That's hallucination, where the data doesn't exist, but it creates. But now, data poisoning is where you're basically injecting data into it. And we are making sure that the data gets poisoned up. So what it will do is, like, for example, if I'm a bad actor and I know what I can do to your stuff, so I'll say, pay me 25 million, I won't do anything. Now think about it. I just do is inject certain stuff, your LLM, so it impacts your business drastically. Because I don't have to steal your data anymore. I just have to inject some small data pieces everywhere. And by the time it takes you to clean that data up and everything else, one, you'll have to stop your business, which is the impact is on your revenue. Second is on your brand. Third is you also have to do a pay after that, because You can't figure it out where it has come from.
See, in terms of the most important things when it comes to data itself, right? Uh, PII is one big bucket, right? Personal identification information. So we basically detect, say, I mean, name, addresses, and say postcodes are the very simpler things. But we also go and detect, say, if there are credit card information, card types, then social security numbers, national insurance numbers, and kind of things like that. So that entire set is actually built across. We look at language challenges and biases that actually exist, okay, as in the sense that if there is multiple, say, languages that are basically used in training, it's detected and classified. While that's legitimate, but you'll have to basically validate it across. Then, say, topics like, say, ban competitors, ban topics, maybe, say, any of those, say, news extracts that typically exist. Some of them are stored as part of, say, PDF files and get into inadvertently for as part of the training data. And the LLM learns about it and starts interacting. So we give a comprehensive view across the data set that is basically used for training itself. If you scroll down a bit, Vijay, for a moment, again, the same type of, say, score is used for each of the data source there. So if we extract the data via MongoDB, then it would basically appear like, say, a CSV file there, which is a table extract, which is normally used. And you can have, say, other set of text documents, PDF documents, say, SQL databases, Snowflake, say, data lake getting integrated, and we have inbuilt adapters, so it validates the entire data set, tagged data set that typically gets into the training bit itself. So there's a, say, again, an interpretation phase, a correction phase that typically happens. So if you can scroll down a bit, you say, yeah. So so we get a very detailed, say, view in terms of why things are failing. Okay, and based on that, if you can, so a remediation is suggested, and we work with the data team for remediating it. It's a comprehensive, say, one that is actually created with scores, with the file names, with topics, and also for the scenarios in which it is failing, which is all the stuff in the top, which I just scrolled. So
So,
this,
so think about how much information exists in form of documents, in form of Excel sheets, PDFs, besides your databases. So look at what it has done. One, it can find which file it is, where that data exists, and it can, in that particular data set, whether it's a CSV file, it's a PDF, it's a data, it's actually able to pinpoint where exactly it is. So remediation becomes way easier. Nobody has to go across and figure out saying, oh, it is somewhere in that file. You go figure it out, right? And somebody has to actually open it up, have a look at it, and then say, what do you mean by it? I read it, I couldn't make sense of it. Then you have to go back and forth. Here, what it has done, it has identified it. It has said exactly where it is. So the person just doesn't have to do anything. They will look at it saying,
okay or
yeah,
not?
it's okay or not. So there's an ability to do another check on it. But what it will do is it identify the source of that information. Within that source, it'll identify exactly where it is, what it has picked up.
so there are 21 such areas, what we have actually incorporated. I've just kind of, I mean, displayed three of them. Quickly, let's move on to the dashboard bit uh, to conclude on this. Okay. Yeah. So in the dashboard, right, on the left-hand side, if you just click on the drop down, there are about 21 different scenarios, just like the one what I showed you, right? Each one has about, say, 8 to 15 parameters. And based on a selection, this dashboard would actually indicate which are those that have, say, the maximum amount of challenges that needs to be fixed. Just click on any one of it randomly. Yeah. So what happens is the first column over there, okay, so we're looking at input data poisoning, which is the test which we just run. So close to about 50% failure rate there based on the, say, ones what we have actually looked at. So 2020, so 20 prompts, 20 failures. That's how it's actually looking like. There's a heat map that's actually produced across all of those 21, say, different probe based cases. And if you can actually click on, yeah. So insecure plugin design, say we've done tests with about, say, 150 ones, and there are about 50 which have failed. So the extent and the quantum of the area for that system that needs to be critically looked at from a training standpoint, data integrations, API to secure it is identified with this dashboard itself. We also have created a view of how it complies with the OWASP 10, which is nothing but the OWASP standard uh, for each one of the areas. So for Gen AI, we have actually created the OS 10 based compliance based on the parameters what we actually extract it out. Just down there, we have, say, EU compliance. So as just like every other compliances, EU compliance also has the, say, people process tooling part of it. This score there is relevant to the, say, tooling system part of it, which is electronically instrumented, while we are adding the process part as well, from a perspective of audit in the next few days. That's what our kind of, I mean, roadmap is looking like for this. So this dashboard will give us summary in terms of compliances, the OWASP alignment, the major problem areas, and a granular, say, view in terms of each area of failure itself, which is what that summary results there typically are indicating. Now, quickly, if we look at the s- last bit, which is about the observability itself. So Vineet was mentioning that observability is one area what we look at. So while this tool mostly looks into validation, but there is certain things that actually run continuously during the life cycle of a Gen AI system itself. So can you click on that observability dashboard itself? Okay. So this is a comprehensive view for the actual real-time transactions that happen, right? So there are about 21 synthetic transactions what we have actually generated out, and we know at a summary what's the cost, what's the, say, average token time and everything that exists for the transaction itself. So this can kind of be aggregated. So can you click on that 3 months average on the top? Yeah. So it can, say, give you a complete average, the cost that exists and everything, and also the systems that actually, say, uh, carry out these transactions. Can you scroll down a bit? So these are all, say, summary of all of those, say, Gen AI system that exists as part of your infrastructure, for what it consumes, what's the transaction, how much user transaction is happening. You can actually even do it into how many, say, text embeddings are working within it. These are all technical parameters that typically gets measured. This is application by application. So I have an application called RAG, I have an application called default, I have an application called testing, right? So this gives a view in terms of the split of the transaction that typically happens, say, within your enterprise itself in a real running scenario. Can you just scroll down a bit further? I'll tell you how we use it from a perspective of, say, security and everything. So average usages, consumption, and also the, say, models that are used. So if you look at it, so there are two models that are actually used there, uh, which is GPT 3.5, and there's a text embedding model. Now it gives a granular view of the transaction and also the pricing. So the way this is used typically is to determine that, say, after a particular time of using it within a month, if you hit the threshold of your spend, you can actually say switch to a different model. Okay, you can go in for a llama, which is actually free, instead of a GPT, and llama can actually be trained in a particular way, right? But GPT would offer, say, more features and kind of things like that. So it's a compromise that's taken with spend versus the selection of it versus the transaction, the delay of it. Some of those, say, denial of services, what I was actually showing, can actually be measured. Can you click on the say details one? Yeah. So typically what we can do is that for every, say, transaction that happens, we create a log out of it. So what we can do is to analyze these to understand if a prompt is, say, basically malicious, which application is accounting for it. So for example, let's take the first row item there. So you have a RAG, which is actually using OpenAI. We're using GPT 3.5 model. Just kind of, I mean, click on that just to open it. Just, yeah. So now, by looking into this transaction, this is actually a real transaction. So the parameters, including time and cost of the transaction and the tokens, the latency, everything is actually, say, recorded. The snapshot of it is recorded for every transaction that happens. And also the prompt and the response. Can you actually scroll down a bit? On the response as well, yeah. So there's a prompt and a response. Now, typically what is done is that, so all of those, say, malicious attempts, everything is actually picked up from here, that, you know what, say, these are the prompts that are actually running, and picked it up. And you also know which system is getting targeted based on those application name and also the model that is used. So every model has got its own set of vulnerabilities. Every system has got its own set of vulnerabilities. So you can immediately ring fence it, or you can basically say, create specific rules for denying traffic from particular IPs which are actually trying to do all this. So this gives a comprehensive visibilities for all applications, all models. When I say models, we talk about it because most of it will be hosted in one of the hyperscalers. So the mechanism of, say, blocking the traffic is going to be different. So this is one of those, say, ones for complete observability, which is used by the team to, say, manage, get a visibility, and also to help, say, plug in any of the incremental threats and breaches that happens. A feed from this can be sent to any system of choice. So any of those, say, New Relics, Datadog, or say Dynatrace, the feed can actually be, say, sent across, so it becomes consolidated at the enterprise level. But at a GenAI setup level, this is basically used from an observability standpoint by the security team, by the planning team, as well as the project team, for actually looking at the costs and everything.
Thank you, Shripati, and thank you, team. Thank you very much.